Hi everyone, in this video we're going to talk about how to calculate expected value. In computing expected value, there are three details that we need to consider. The first is the cost to play or the initial investment that we need to make. The second is the profit earned in each outcome. And the third detail to consider is the probability of each outcome occurring. Let's take a look at an example problem. Bob wants to know if you would play his game. It costs $2 to play, and you do not get the $2 back regardless of whether you win or lose. The game consists of selecting a colored marble from a bag. Selecting the one green marble wins $30. Selecting one of the 4 red marbles wins $3. Selecting one of the 8 white marbles wins $1. And selecting one of the 7 black marbles wins $0. Is it in your favor to play this game? So let's consider each of our 3 details. First, what is the cost to play the game? We found that we had to pay $2 to play Bob's game. Second, what is the profit earned for each outcome? Remember that profit is your winnings minus what you had to pay in order to play the game. So for the green marble, we win $30, but paid $2 to play, so the profit is $28. For the red marble, we win $3 and pay $2, so the profit is $1. For the white marble, we paid $2, but won only $1, so we have a negative $1 profit. And for the black marble, we win nothing, still had to pay the $2, so we have a negative $2 profit. Third, we need to know the probability of each outcome. Since there was 1 green marble, 4 red marbles, 8 white marbles, and 7 black marbles, there is a total of 20 marbles in the bag. So for green, 1 green marble out of 20 is a probability of 1/20. For the red marble, we have 4 red marbles out of 20. That's a probability of 1/5. For the white marbles, there are 8 white marbles in a total of 20. So that's a probability of 2/5. And finally, for black, there are 7 black marbles in the bag of 20. So the probability is 7/20. Now that we have each of these 3 pieces of information, we can compute the expected value of the game. Let's organize all of our information in a table and do our calculations. So I've listed each of the outcomes, the profit for each outcome, the probability of each outcome occurring, and this last column is for my computations. So here we go. For green marbles, the profit's $28, and the probability is 1/20. So the first thing I need to do is take my profit and multiply it by the probability. So that means that I have $1.40. For the red marble, the profit is $1. The probability of drawing a red marble is 1/5. So $1 times 1/5 gives me 20 cents. For the white marble, the profit is negative $1. The probability is 2/5, which gives me a product of negative 40 cents. And finally, for the black marble, the profit is negative $2. The probability of drawing the black marble is 7/20, so profit times probability gives me negative 70 cents. I add up this last column to get my expected profit. So $1.40 plus 20 cents plus negative 40 cents plus negative 70 cents gives me an expected profit of 50 cents. That means that this game is actually in the player's favor. Now notice that we can't actually win a profit of 50 cents from playing the game once. What this expected profit really means is that if we keep playing the game, the longer we play the game, the more likely we are to end up with a 50-cent profit on average over the course of all the trials. Now let's look at an alternative method for calculating the expected value. We still need to consider 3 details. The first detail is the same. We need to know the cost to play or the initial investment. The second detail, we're going to replace the profit with the revenue earned in each outcome. And the third item is still the same. We need to know the probability of each outcome. So, our first item, what is the cost to play the game, is still the same, $2. Our second item changes. Now we're interested in the revenue earned for each outcome. So, for drawing a green marble, we end up with a revenue of $30. For a red marble, $3. White marbles are worth $1, and black marbles are $0. Third, the probability for each outcome remains the same. We still have 20 marbles in the bag, 1 is green, 4 are red, 8 are white, and 7 are black. With this information, we can compute the expected value of the game. So now let's take a look at a chart. Our first column, we're going to have the outcomes. The second column, we're going to have revenue. The third column, we're going to have probability. And we're going to do our computations in the fourth column. So, for the green marble, the revenue is $30. The probability is 1/20th. We multiply these together and get $1.50. For the red marble, the revenue is $3. The probability is 1/5, which means revenue times probability is 60 cents. For the white marble, we have a revenue of $1 and a probability of 2/5, which means revenue times probability is 40 cents. And finally, the black marble earns a revenue of $0 times a probability of 7/20 gives us back $0. Summing up the revenue times the probability for each of our 4 outcomes gives us the expected revenue. So this game has an expected revenue of $2.50. But we have to play $2 in order to play the game. So that means to get our expected profit, we take the expected revenue, subtract the cost to play, and we still end up with an expected profit of 50 cents. So again, we draw the same conclusion. Since the expected profit is positive, the game is in the player's favor. Notice we get exactly the same answer regardless of which of the 2 methods we choose to use. So let's do a quick recap of our 2 methods for computing expected value. In method 1, we compute the profit of each outcome. Then we compute the probability of each outcome. Then we multiply the profit by the probability for each outcome and add all the results of step 3 together to find the expected value, or the expected profit. In method 2, we compute the probability for each outcome. We multiply the revenue by the probability for each outcome. We sum the results from step 2, and then, finally, we subtract the cost from the result of step 3 to get the expected profit. Remember that each of these 2 methods should give you the same result. If you do method 1 and then method 2 and you get a different answer, that means there's a mistake somewhere. Check your arithmetic and also check your probability distribution. Remember that all the probabilities have to sum to 1 in order for the probability distribution to be complete and correct.